29.5 here, I have a couple examples to go over with you. This section is going over it using a continuity correction. So the continuity correction is adjusting for the binomial distribution, which remember the binomial distributions only had whole numbers that were being used because it was counting the number of successes. So to adjust to a normal distribution, which is continuous, from a binomial distribution that is a discrete random variable, we have to adjust the values a little bit here. So here, for instance, for this first one, if we want to find the probability that the values are between 28 and 40, so there, if we're talking about between 28 and 40, that means we are not including those values to begin with. So if we think about this on a number line, for instance, we had the 28 and the 40. Remember, the smaller numbers go on the left side, bigger numbers go on the right side of a number line. If we are between that, what we'd have is we have open circles at those two endpoints since they're not being included there. And we'd have everything in between there. But since we were talking about the original case being a binomial, it was counting the number of successes. If we want between those, what we do is we need to adjust this, that the first value that would have been included here for the binomial case would have been a 29, and the first whole number in between the 28 and 40 that's less than 40 would have been 39. So really, whenever we adjust this for the continuity correction, what we'd have to do is we'd include a 28.5 and 39.5 to include just a little bit more than those first values that were actually included in the binomial case. So here in this case, what we'd have is we'd have it going from 28.5 to 39.5 for the probability once we do the continuity correction. So once again there, since we're going between 28 and 40, that means we're not including those. So the first whole number that's being included there would be the 29, and the last one included there would be 39 in that interval. But since we have to adjust it here, we need to go out just a little bit further for the normal distribution than those first values that were included in the binomial. So that's why we went down to the 28.5 and up to 39.5. And then part B here, we have another one that's similar to this to practice this again. So I know these can be confusing at first. So if we want less than 38, that would mean we're not including this. So that would mean that the first value we're actually including there would be the 37. So if it helps, you could just include that first value and show everything less than it. Because remember, for the binomial cases, you only had whole numbers that you're working with because you're counting the number of successes. So here that would mean if we want to include just a little bit more than that for our interval, whenever we're dealing with the normal distribution, adjusting there, we'd want to go right above that 37. We'd want to have less than 37.5. So for part A, there is between the 28.5 and 39.5. For B there, it's less than 37.5 once we adjust for this continuity correction. Continuity correction is adjusting it to a normal distribution rather than a binomial distribution. So that way it's easier in general to find our probabilities rather than having to use the formula we had for probabilities for the binomial case before, which can get very long if you have a lot of values, as you saw back in chapter 4. And then we have the probability of greater than 52. So if we're looking at greater than 52, then the first value that's greater than 52 that's included in the binomial case would be the 53, and then everything above it, because 52 is not included, since it says greater than, so then that would mean that the first value for the continuity correction that we'd have, that would include just a little bit more, would be that we would need it to be greater than 52.5. So we have to include just a little bit more in our interval. If it had said greater than or equal to, then we would have had to have gone a little bit less than 52 instead. So it'll always be up or down by 0.5, kind of like whenever we did our class boundaries before, back at the beginning of the semester. It'll always be up or down by 0.5. We'll go up if you're not including that first value and we're looking for above it, like in this case for greater than 52. If it had been greater than or equal to 52 instead, then we would have gone down to 51.5 and then included everything above 51.5 instead. So it depends on how it is phrased there. Example 2 here is going through how we can use this type of thing. So here we have a survey reports 70% of students in a particular school participated in at least one sport while attending the school. You randomly select 25 of those students and ask them if they participated in at least one sport while attending school. What is the probability that more than 20 of them participated in at least one sport? So we definitely don't want to go through and have to calculate this like we did back in the binomial case, because otherwise we'd have to go through and calculate it for 20 and 21 and 22 and everything above that until we got to the 25 there to find the probabilities and then add those all up like we did before. So the quicker way here now is to do this continuity correction. So here in this case, if we're talking about more than 20, so that means we're not including the 20, but everything above it. So the binomial case, once again, just use whole numbers. So that means the first value that was included there was 21. But we have to include just a little bit more than that here. So we'd go a little bit below that. So that way we're including all of that interval plus a little bit more. So really what we're trying to find here is the probability of our value of x being greater than 20.5. That's really what we're trying to find there. So we want our value to be 20.5 or above there. So in order to find this, we're going to have to find our z-score first of all. But remember, for a z-score, we're going to have the mean and the standard deviation here. So just a reminder from back in our binomial case in chapter 4, to find our mean here, we do our n times p. And remember, it's the sample size or the number of trials. So in this case, we had randomly selected 25 students, so our n is 25. And p, remember, is probability of success. In this case, looks like it was 70%, or 0.70 as a decimal. So for the mean here, if we calculate that out, we get 17.5. And then for our standard deviation, I'm going to abbreviate standard deviation as S, like we had before, since it was dealing with a sample for the standard deviation. And just a reminder from our binomial case again, to find that here, we do our n times p times q to find the standard deviation here. So rather than having to go through and set up a long table like we had to before, we can use that shortcut since we know it's a binomial case. So in this case, whenever we're setting it up, we'll have the square root of 25 times 0.7 times 0.3. Remember, your q is 1 minus p. So here, if we calculate that out, we get approximately 2.29. Remember, in general, go out at least 2 decimal places whenever you're doing these. So then to calculate your z-score, remember you do the value. So in this case, the 20.5 was our value, minus the mean, which we calculated was 17.5, divided by the standard deviation, which we got as 2.29. And then you go through and calculate that. So for our z-score here, we get approximately 1.31. Remember, for z-scores, those ones should always round to decimal places, because our table that we have only goes out 2 decimal places in our chart. So we don't need to round out any further than that and use your normal rounding rules. So then what you'll want to do is look up 1.31 in your chart. To do that again, you go down to 1.3 on the positive part of your z-score chart, and then over to 0.1. So if you do that there, you should get 0.9049. That's the area that it gives in the chart there. Remember, your areas also correspond to your probabilities here. But here in this case, we wanted x as being greater than 20.5. So remember, if we want greater than something, or if we want to the right of it, we then have to do 1 minus that probability, or 1 minus that area. So to finish finding our probability here, we have to do 1 minus that to get the area to the right, or that probability of greater than instead of less than. So then for that, we get 0.0951 there. So then that would be your final answer for your probability here. So if we're writing this out from the beginning here, our probability, it ended up being 0.0951. So it's kind of connecting the dots from what we did in chapter 4 and 5 and putting it all together here.